Hello, dear students and teachers. You're welcome to another video by Boss Willis. This is my channel, The Mystified Mathematics. Today, I'm going to teach you how to solve some Year 10 questions. And this is the first of my series, How Prepared Are You? My students in Christian High are preparing for their mock and I want to help them. Now, let's start with the first question. The first question has to do with modulus graphs. Okay. Now, we have been given something like this and they want us to sketch the graph stating the intercept with the others. So this is what you can do here. um, if you take the first function, so here you can expand. Many people don't know that you can actually expand your modulus function, like how you expand a quadratic. You can actually expand, so this number, the number in front, to multiply each of the terms here, so you get something like this. Now, I believe you know how to sketch a straight line. Well, if you don't, there's no problem. I'll walk you through. So basically, if you are sketching a straight line, all what you need is the x-intercept and the y-intercept. Now, the y-intercept is the same as the number that stands alone. This one is the same as -4 here. So let me just say here is -4. Or let it come down a little. -4. Okay, -4. All right. Then also, I found the y-intercepts. Now the x. If you find the x-intercept, you can say that at x-intercept y is equal to 0. You could have used the same thing to find the value of y. So at x, y is equal to what? 0. All right, so I will have this one come here. I'll have 4 is equal to this. I'll divide both sides by 4, and that should give me x is equal to 1. So my x is 1. Okay, so what can I do at this point? I'll just pass a straight line through this straight line. It's not hard, right? Okay, so when you finish this, all what you are supposed to do is that modulus means that you are supposed to reflect the part of the graph that's below the x-axis. You just bring it to the top. You just bring it above the x-axis. That's it. So here is -4, so it becomes +4. Then when you do this, you just pass a line through it. That's it. You are done. So when you finish, you can wipe this part, make it broken lines, or you can clean the whole thing. I mean, that part that's below the x-axis, you can clean that part, the whole thing. That one too is also cool. You can clean the whole thing if you like. But I prefer to leave it as broken lines. Now, let's come for the second one. So the same idea. You're going to find the x and y intercept. I told that the y-intercept is the one that stands alone. So here is +2. So +2 should be somewhere here. Okay, it's already above the x-axis, right? Now, that's the y. What about the x? At the x-axis, y is equal to 0. So do this. When this one comes, you add -2. You divide both sides by 3, you get this. Okay, so your x is going to be -2 on 3. So I'm going to have something like this. Just a line passing through the 2 points. Let me use another color for this one. Okay. Now I'm going to do the other side. So you know that if here is 2, the the reflection would have been -2, right? So I just pass a line through this. Then when I finish, I clean this one with broken lines. So that's how my graph is going to look like. All right, let's look at B. Now we are supposed to solve this inequality. We have already established that the first one can be written as this. Now I'm going to introduce the equation sign. When I finish, then I convert it to the inequality form. Okay. So here you just write your normal expression. Don't change anything. Just write the normal expression. Repeat the same thing again. However, the second one you're going to negate the whole expression on your right. Okay. So now this will give us, when this one comes here, you have -3x. Okay. Oh, this is 4. Okay, so I'm going to get 2 on 7 and 6 if you solve this. All right. And now let me show you a shortcut for solving inequalities. Now, if you have a function that is less than, okay, less than a given value, let's say less than e, all right. So what you can do, or less than, let's say, let me say less than 0 or less than any number. What you can do is that if it's less than, your answers are always going to be less than. Then the number that is small will come first, followed by the number that is big. However, if it's greater than, then you're going to have 1 to be greater than and 1 to be less than every time. Now, this one will go with the big one. The greater than goes with the big one, as the name connotes, and the less than will go with a smaller value. So let's say if I have -1 and 3, it will look like this. The smaller one is -1 and the big one is 3, right? And here it will look like this. X is greater than 3, x is less or equal to -1. Now this one also holds for this your normal greater than without the equal sign. So we are going to apply this one here. Now for quadratics, for this shortcut I have taught you to hold, it only works for minimum graph. That's for quadratic, okay? Eh, minimum graph. I've not checked for polynomial, but I know that it works for quadratics and straight line modulus graphs. So, or straight line inequality. So you are going to get, your answers are going to be this and that, because it's less than, right? So your answer is going to be less than. What if it was just less than without equal to? That's why I said that it's going to be just this one. All right, nothing difficult. Mathematics is not difficult. All right, let's look at the second question. Now, e to the power y is plotted against this x squared. So that means my y is now this and my x is now that. Okay. And they gave me the gradient. Oh, these people are so gracious. They gave me the gradient. So my gradient is -3. It passes through this point. So if I have a normal equation, equation of a straight line is given by this. Y is equal to mx plus c. Now my gradient is -3. I can find the y-intercept using this point. My y is 5.85 and my x is 4.3. Okay, so now let's solve this one. 5.85. When this one comes, it becomes plus. So that plus 3 times this. Okay, I'm getting 18.75. 18.75. Or if you write um 75 on 4, that's also correct. So what do you think I can do with this value? So right now my equation becomes this one. It becomes this, right? Don't forget that you said that your y can be represented by e to the power y. And your x is now x squared. Is here. Okay. Now they say that we should find y in terms of x. So if you want to find y in terms of x, what can you do? Can you guess? Okay, you take lane of both sides. I can hear my student telling me that I should take lane of both sides. Okay, so I'm going to take lane of both sides. And you know that the lane will get rid of the e. So I'm going to be left with what? Y. All right. So I've expressed y in terms of x. Now there's a follow-up. Find the values of x for which y exists. Okay, so let me go back to my equation. Now, this is a natural logarithm question or logarithm question, all right? When does your logarithm function exist? That's when your argument, this is the argument, your argument must be greater than zero. That's the expression in the bracket. It must be greater than zero, all right? We treated that under logarithm. You can watch my video on logarithm. So I'll take my argument and I'll make sure that it is what it is greater than zero. Okay, so you're getting a quadratic with no x term. You have x squared, so it's a quadratic. So what can I do here? I can divide throughout by, let's divide throughout by -3 and see what will happen. Okay, that's -3. 6.25. 6.25. All right, then we can solve this quadratic. Oh, don't forget that I'm dividing throughout by negative number, so my inequality sign will change. So I'll take square root of both sides. So this one should give me plus or minus 2.5. Now I told that if you have less than inequality, if you have less than, you're going to get, and you have two values, it's going to be less than, less than. Then the smaller value comes first. What's the smaller value? Negative 2.5. What's the bigger value? 2.5. So small value here, big value there. All right, so let's look at example 3. No example 3, but question 3. Okay, question 3. You have been given this quadratic. You are supposed to determine the nature of the quadratic, whether it is to have two distinct roots, equal roots, or no roots. Um, so this one can be written as, let me put this one in a bracket, this one in a bracket. I can cross multiply. You know, your algebra must be very good. That's why we do math D in Cambridge. So when I expand this, let's see what will happen. I'm going to get 12x squared plus 11x plus 2 is equal to, okay. Now I try to form a quadratic, right? So here 12, when this one comes here, the 5, you subtract 12 minus 5, you get 7x squared. 11 minus this, you get 9x. Then 2 minus -3. Or when it comes, it becomes plus. So 2 plus 3, that'll be 5. All right. So if you are talking about the nature of a quadratic graph, then you have to make use of the discriminant. You know this is b. B is 9. So 9 squared for a. A times c, that's 7 times 5. That'll be 35. What am I getting for this? I'm going to get 81 minus 140, which is -59. So I'm going to get a negative value for my discriminant. And you know that if your discriminant is negative, then we don't have a real root. So no real roots. Yes, that's it. No difficult, right? Okay, so this guy is quadratic. This guy is quadratic. Okay, so they like giving questions like this in the exponential form, so you should watch out. All right. Now here I will say that this is the same as 12 over x to the power 1 over 3. It can be written as this. Okay. So it's actually a quadratic, but they are trying to hide its form. So x to the power 1 over 3 is equal to y. So this one can be written as, what can I do at this point? I can multiply throughout by y, and that will give me, so I'm going to have a quadratic like this. Let me multiply throughout by negative y rather. Negative. So here will be negative, positive, positive. So y squared plus 4y minus 12 is equal to 0. Okay. So y times y should give me y squared. 6 times 2 should give me 12. Okay. And I cross like this. I'm going to get 6y. Here I'll get 2y. What can I do to these two to get the middle one? If I add and I subtract, I'll get uh, 4y. So I bring the same sign here, plus, minus. So those two expressions are going to be my factors. So y is equal to negative 6 or y is equal to 2. Don't forget that you said your y is equal to x to the power 1 over 3. So if y is equal to negative 6 and I want to find the value of x, what do? I just multiply this one by the power by its reciprocal. It's 3 over 1 or 3. Let me do the same for this. Let's check the value. Negative 216 to negative 216. Okay, what about when is equal to 2? Okay, so you have x to be 8. Not difficult, not difficult at all. All right, a polynomial is such that p of x is 6x cubed plus x squared minus 12x plus 5. Find the remainder when p of x divided by x minus 2. So what do? You just take this one, equates to 0. It will give you the value of x. X is what? 2. So you just put that value into the expression. There's no reason why you should get 0 in add math, because they always give you simple questions like this as your first question. I am baffled when some student gets 0, because you should be able to score this, right? So your remainder is what? Your remainder is, you can just write your remainder. Your remainder is 33. And this is from the remainder theorem. Now, show that this is a factor of the polynomial. So the same idea, you just come and put the value of x here. So here, 2 minus 1 is equal to 0. So x is equal to 1 over 2 when you solve this one. Okay, let's solve this one and see what we will get. Okay, so the remainder is 0. And you know that in polynomials, if your remainder is 0, that means that that factor, this will be a factor of the polynomial. This will be divide the polynomial without a remainder. So the remainder is 0. Okay, so that means that 2x minus 1 is a factor of p of x. All right, hence write p of x as a product of linear factors. Now there are 3 marks. So I'm going to do my long division. We have 2 ways of doing this. You can use the long polynomial division, or you can use the syntactic method. Let me teach you the long polynomial division. Then, or when I finish, I'll come to the syntactic method. Okay, I've changed my mind. I'm going to show you the syntactic method first. So that one is very fast, easy, and very fast. Okay, and so you just bring, this is a factor, right? The value of x, you bring the value of x here, one of your factors. So I know this one, the value of x is what? 1 over 2. So 1 over 2. Then I write down all my coefficient, the coefficients of this polynomial. Let's start with 6, then 1, then negative 12, then 5. Okay, so when you finish, you just draw this number down, bring it down. Then let me show you how you are going to get your quadratic values. This half times this, what are you going to get? You're going to get 3. So the value that you get, you just put it here. Then you add this one, you get 4. Then repeat the cycle again. This times this, what will you get? You get 2. Then you add negative 12 plus 2, you get 10. You multiply it again, half by 10, you get what? You get 5. Oh, this is negative 10. So, yes. So here will be negative 5. So when you finish, you add this one. If you add this one, you get 0. This is the remainder, eh? This is the remainder. Okay, so indeed it shows that one this factor was 2x minus 1 is indeed a factor of the polynomial p of x. So now the number that you have gotten here will form your quadratic. Okay. In other words, this is your quotient. This is your quotient. So don't forget that your factor is this 2. Okay. And you know this one can be written as, right? It can be written as this. So if I multiply this and this by 2, I'm going to get 2x minus 1 over 2, right? So in other words, my factor can be written in this form. Okay. So now p of x is equal to the this factor, which is the same as this, multiplying this. Okay, now here I can write this as they all have 2 in common, eh? So I can factor 2 out. So let's see, I can, this and this will cancel, right? So my polynomial can be written in this form. Okay, so when I finish, what do I do? I solve this quadratic. Okay, if you break this quadratic down, you're going to get x minus 1, 3x plus 5. So that will be my final answer. They say we should express it as products of linear factors. That's what I've done. Each of them is a linear factor. All right. Or you can use the synthetic division. I mean, you can use the long polynomial method. Um, so you're just going to divide the first term here by this, and that should give us 3x squared. Then you multiply this by this, okay, and you get this. This time this should give you negative 3x squared. Then you subtract. I prefer to put in a bracket because it's an expression. This will give me 0, so I don't need to write anything there. This minus this becomes plus 3 plus 1, so 4x squared. Then I drag this one down. This will go here, what? 2x. So I multiply the 2x by this factor, and that should give me 4x squared minus 2x. Okay. Negative 10x. When this one comes a plus 5. Okay. This will go here, what? Negative 5. Then you multiply negative 5 by this, you get So that's it. So you can also do it like this. So you see, I've gotten my quotient. Yes, then use it to solve your equation. All right, so hence let's solve this one. If you look carefully, you see that your polynomial is the same as the one here. We are applying a little bit of trick here, okay? But don't forget that, or you can see clearly that x has been replaced by what? Sine x. So that means p of x can be written as, wherever you see x, you put sine theta there. I bet you have not seen a question like this before. Eh? I always tell my student that there's always a first time. That's why you should always look for questions. Otherwise, your teacher will look for the questions for you. So this one is equal to what? 0. So you should be able to solve this quadratic. So you take each of the factors and then you equate to 0. Then you solve. This one is equal to minus 1 is equal to 0. Then I have sine theta minus 1 is equal to 0. 3 sine theta plus 5 is equal to 0. Okay. Sine inverse of half, that will give me 30 degrees. I know that's off here there. Okay. Sine inverse of 1, that's 90 degrees. All right, let's come here and see. When this one comes here, negative 5. Can you have sine inverse of this number? No. Why? Because we say that for the values of sine theta must range from negative 1 to positive 1. But here, this is the same as negative 1 point, is it point 6? Yeah, point 6 or so. 0.67, somewhere around the figure. So that means that it's out of my range. Okay. Let's see. Sine inverse of negative 5 on 3. You see, math error. Math error. So it can't be done. So that one is not part. So there's no solution for that. Eh? No solution. And besides, it will even be out of the range if it would work because negative. You see that here is 0 to 90, so it will be in the first quadrant. So all the values that you're looking for must be in the first quadrant. So sine is positive in the first quadrant, so it cannot be an answer. All right, so that is it for question number 4. All right, so this is number 5. It's on binomial. Yeah, so write down in ascending powers of x the first 3 terms of this binomial expansion. Okay, now if your first term is 1, if you expand it, no matter what the power is you are still going to get 1 as your first term because it's going to be c, and this will always give you 1 no matter what. Now the second term you can just multiply this by this. All right, remember how we do quadratics? We expand a binomial with the power 2. You just multiply the first term by the second term by the power. So the second term is always multiplication of all the terms, and I mean the two terms and the power. So this will give you 4nx. The third term, so that one is going to be n combination. The first term is combination 0, combination 1, combination 2, and combination 2. Then you just bring this one, and the power here is the same as the power here. I mean, the number here is the same as the power here, okay? So now let's solve this one and see what we are going to get. So this is the same as n multiplying n minus 1, 2 times 1. You know 1 to the power, this will still be 1. This will give you 16x squared. So this will give me 8. Can I do any other cancellation? No. So I'll get 1 plus 4nx, 8, and the 8 is from here, x squared. All right, so that's it. Now the b, they say that in expansion of this, the coefficient of x squared is given by this. Is this okay? So what do you think you can do? Can you pause the video and try this one yourself? All right, I want to believe you pause the video to try it yourself before copying my answer. So don't forget that this expression is, you have expanded it and you have gotten this one, right? Okay, now it's multiplying 1 minus 4x. Now you are interested in the coefficient of x squared. Okay. Now if I multiply 1 by 1, will I get x squared? No. 1 by this, will I get x squared? No, I get x. Okay. So this one is out. Let's check. 4nx by 1 doesn't help. 4nx by negative 4nx. By negative 4x. It works. So let's see. Um, this by this. Okay, so you don't need to expand the whole thing. It makes your work cumbersome. So just look at it and think. What about this by 1? Will I get x squared? Yes, I will. I have x squared inside. And so get it by 1. And this by this, I'm going to get what? X cube. So I'm not interested in that. So but you are interested in the coefficients. So this is the same as negative 16n. I'm focused on the coefficients, so I'm not bringing the x squared. And this will give me 8n squared minus 8n. Okay, so now they say the coefficient of x squared is equal to what? This. So the whole thing is equal to 6032. So you can see that you're going to get a quadratic. Quadratics are very important. Negative 16 plus negative 8. I'll get this. Very, very important in hard math. So here I've just picked my calculator. Calculator should save me. Okay. Now you know if you want class with calculator, I'm your best plug, right? Don't stress yourself and go to town for them to give you a fake one. It's better to spend a little money and get a quality one from me. So that's just by the way. So n is equal to 29, n is equal to negative 26. N is equal to 29, n is equal to negative 26. But you see, sometimes they mark your linear factors. So make sure you write like this for them, right? You- But you know that our n cannot be negative. So therefore n is what? 29. Hmm? Our n cannot be negative. N is always a positive number. It's always greater than 0. So our n is 29. All right, now find the independent term. Um, so recently I have been thinking about this and I've found an easier way of doing this unknown term, finding an unknown term. All right. First of all, you just consider only the variable. Consider only the variable. And when you finish, you come and consider only the numbers. Okay. So now here the variable, let me write it in the index form. Here is x, eh? So just write x, put in a bracket like that. Here is 1 over x to the power 4, which can be written as this indices, right? Now remember that the power of the second term is always the same as what the one here. I even said it in this question. The first one I said it here. This is the same as the power here. So here's r, right? The power here is the same as the value of r. Then this side is n minus r, where n is your the power of your binomial. So it's going to be the same as 10 minus r. So this one, and now for your independent term, the power of x is 0, or the power of your variable. It can be any variable, it can be x, it can be y. The power is what? 0. So this is going to give us, you're going to do a little bit of indices here. So they are multiplying, so you can add the powers, right? So you're going to get this. And negative r minus 4r. You know what you're going to get, right? So this will be, since the bases are the same, you equate the powers. So r will be what? 2. If you solve this, you get r to be 2. Now, now I'm going to consider only the numbers, starting with the combination, which is 10 combination 2. I found the r already, it's 2. Don't forget that this is the same as 1 over 2. Okay. And the power here is 10 minus 2, which is 8. The next number we have is negative 8, and the power is the same as the r here. Let me go for my calculator. So if I calculate it, I'll get 45 on 4, or 11.25. Okay, number 6. We have this, and this is a question on trigonometry. They are giving you the domain or the interval. You are in the You are here and here. That's the third and fourth quadrants. So I use all silly tomcats. If you have been following my video, all silly tomcats, or some people call it ASTC. Now here, tan is positive. Okay, tan is positive here, and as I can see, the value of tan is positive here. So, however, tan is not positive here. So I mean, I can't be in the fourth quadrant. I'll be in the third quadrant. I'll be in the third quadrant. So please take note of that. So everything that you are doing to be within the third quadrant. So they say I should find cos. Okay. Um. So I can use the trig identity 1 plus tan squared theta is equal to sec squared theta. Okay, and I'll take square root of both sides. So sec theta is equal to, what is your tan value? Squared, okay. So this is the same as 6/5, root of 6/5, which is the same as, which is the same as sec theta is equal to root 6/5. But it's going to be plus or minus, right? But the value that I will go for will be minus. Why? Because sec is a function of cos, right? It depends on cos, and cos is negative in the third quadrant. Cos is negative in the third quadrant. So it's going to be negative this, okay? And I'm looking for cos, not sec. So when I finish, I can find the reciprocal of both sides. If I turn it upside down, left upside down, right upside down, I'll get this. So that's the value of cos. Sine theta, okay. I can also apply sine theta squared plus cos theta squared is equal to this. So basically, I make sine the subject, right? But don't forget that because it's square root, you get plus or minus for this value. Okay, so this will give me 1 minus 1/6, the square root of this. And the square root of that is the same as plus or minus root 1 over root 6. Root 1 is 1, root 6 remain the same. But is it going to be plus or minus? It will be minus because in the third quadrant, sign is negative. Okay. All right. So here, the final thing is I should find sec theta plus cot theta. Okay. I think I have sec theta here. Oh, I'm so lucky. I found it here. Negative set 6 over set 5. Cot. Okay. So this is the same as tan over 1. So 1 over tan, it will give you this. That's the reciprocal, right? If I find the reciprocal, I'll get this, right? But don't forget that 1 over tan is the same as what? 1 over tan is the same as courts. So what's the LCM? The LCM is going to be set 5. So I'm going to have this. Okay, and I want to write this in their form where the square roots come second. So this is the same as, okay, so that's it. For 2 points. Oh, but this one they didn't try all this plenty work for 2 points. Sometimes I feel the pain of students, eh? Maybe they think that many people cannot answer. That's why they did like that. Now the final question. Okay. You have to show that this is equal to this. All right. So this is what I'll do. I'll put this expression in a bracket like this. This one is also an expression. This one expression. I'll cross multiply, and that should give me. Normally, I break it down to sine and cos, but in this case, I feel like it would be easier to just do it like this. If you break it down to sine and cos, you can do it, but it will look. I think it will be more complicated. How do I know? Someone is asking, so how will you know? I know it by solving a lot of questions. I must have solved more than 200 questions on trigonometry. So, and the denominator is going to be this times this, right? So just like you have some like um, this times, if you are solving fractions, you know how we do that thing. Then this times this, then this time that's what I'm applying here. Okay. So like you have 1/2 plus 3/4 is the same as this times this, 2 times 4, which is 8, then 1 times 4, then this times this. Okay. And this is the same as 10 on 8. So you see that it's the same as 5 on 4. And it's correct. It's correct. You can even confirm the calculator and see. My class is calculator. In this modern day, you are still using that black calculator. Okay, so it's correct. Learn new tricks. It will really help you to move very fast. Okay, so now if I expand this one, I'm going to get 1 time this bracket to give me the same bracket. 1 times any number is the same number. This time this, I'll get tan theta. This time this, I'll get tan theta cos theta. 1 times this bracket will be the same bracket. This time this minus tan theta. This time this, I'll get plus tan. It's no go there. Wow, it's very long. Cos theta. Okay. Normally I like to hold on to my denominator before I get my final. I simplify my numerator because I don't know whether they can cancel. So don't be in a hurry to, I mean, get rid of it or simplify it. This and this will subtract. This and this will subtract. Mm, can something subtract again? This and this will subtract. Okay. Mm, so 1 plus 1, I'm getting 2. Then this plus this, that will be 2 tan theta cos theta. Okay, all over. Okay, so right now I can see there's no correlation between the numerator and the denominator. So I can break it down. This is the same as difference of two squares. So the square of this, the square of that, and this should give us tan is the same as sine theta over cos theta. So this is 1 minus what? 1 minus cos square theta, and it's an identity. You remember this? Okay. So here, if my cos comes here, cos square theta, I'm going to have sine square theta to be equal to this. Okay. So the whole thing here is the same as what? Sine square theta. This and this will cancel. So my numerator is going to be what? Let me minimize. I've used my space. My numerator is going to be because this and this have cancelled, and so they are gone, right? It's like they are gone, something like this. So they have two in common, so I can factorize the two. So if I do so, I'll get this. All right. So hence the proof there. That's it. I'm done. Maybe I should put it here so that it will look better. Okay, they say hence. Whenever you see hence, that means you are supposed to use your previous answer to solve this. And previously you said 2 two brackets 1 plus sine theta is equal to over sine square theta is equal to 3. All right, so I don't want to use my final one. Well, you can use the final one, but I want to use the one just before the final one. Or should I use the final one? Any of them will work, but I prefer to use the one just before the final one. So this time, this okay, using the final one would have been straightforward. So that means the whole expression here is equal to this. Okay. So okay, I. So I we are going to you say hence. Whenever you see hence, that means you are supposed to use your previous answer, right? So we know this one already. So I can apply to solve the question. So here I can multiply this by this. As I said, if you are confused about this topic, if you are confused, that means that your algebra is not good. You will need help. All right. So please, that means you have to work on your algebra. So here, I know that I can say that let sine theta be what x. So I have 3x squared minus 2x minus this. Can I solve this quadratic straightforward? It looks it looks like the discriminant will be some way. So let me use my calculator. That's if it's a calculator paper, eh? 3 minus 2 minus 2. Oh, I'm right. So x is equal to 1 plus set 7 over, is it over 3? Is it over 3? Yes. What's the next answer? Minus. Plus or minus? Okay. What's the decimal equivalent? Um, okay. So this is the same as 1.2153, and this is the same as negative 0.5486. All right. So don't forget that you said here. You said sine sine theta is equal to x. Your x is 1 point this. Okay. So you can find sine inverse of this. Is this one going to work? The sine value is more than what? 1. You told that, remember we said that before you can solve this, your sine value must be between negative 1 and what? And positive 1. So this one, no solution. You can't solve this one. How about if it's negative 0.5486? Okay, so I'll take the sine inverse of 0. This. Why didn't I bring the negative sign? Because I'm finding the acute angle. If I find the acute angle, you don't bring a negative sign. So let's see, sine inverse of this. I will need my calculator here because this is not a mass no angle. If it's a mass no angle, you can be told to do it without a calculator. My calculator is in, you must make sure your calculator is in degrees because the answer is in degrees. So I'm getting 33.3. If it's degrees, you can leave it to one decimal place. In fact, you're supposed to leave it to one decimal place. But please, can this be my answer? No, because sine is, the value is negative, so I must be here or here. I can't be in the first or the second quadrant. But the acute angle I found is here, that's 33.3. So I can be here or here. And you see that the interval is up to 360. It's up to 360. So this is 180 plus 33.3. And here's 360 minus 33.3. And that should give us 213.3 degree and 326.7 degrees. So that will be my answer. Leave it there. It shows that you have worked. That's your working. All too soon, we have come to the end of this video. Don't forget to like and subscribe. Tell your friends about this video. Share the link with people from other schools. And I'll see you in the next one. Have a lovely day. Bye.